Well, hello guys, and welcome back to my channel. Have you ever wondered how cameras work? I know I always have. So, I understand how a camera works as far as using a camera. But when I push the shutter button, what even happens? So today I'm starting a new series in which I'm going to address just that. I'm gonna put together some of my knowledge of photography and computing as a software developer, a little bit of physics and chemistry, and I'm gonna teach both of us how a camera actually works. So let's get into it. Now I have put together a few notes here, so if you see me kind of glancing down, I'm just kind of looking at my iPad that I have here in front of me to remember all of the details of this. So the first thing that we need to get into is how exactly light works. You need to understand a little bit about light before you can really understand how a camera works. We won't talk about particles or waves and things like that, but just the basics of how our eyes see so that you can understand how a camera can see as well. So the light that comes from a light source, if that's the sun or another light, maybe your flash, I have a ring light right here, that is being put out most likely in multiple colors. And so if it's a white light, for example, it's probably going to have all the colors of the rainbow in it. And those different colors are actually coming from the different frequencies of light that are coming from it. So the light's being emitted at different frequencies, and our eyes perceive those different frequencies as different colors. Now, as you're probably aware, we can only see a very small portion of the light that is actually available that exists. So other things like X-rays, microwaves, cell phones, those things are all actually relying on other frequencies of light that are outside of the visible spectrum, which our eyes don't detect. So you could make a camera that detected other frequencies of light, and that's like how the X-ray works. There's infrared cameras, things like that. But for most purposes, we make cameras detect what our eyes do so that we can capture what we see in the world around us. Now, when light is traveling and it hits an object, there's two things that can happen. It can either bounce off the object or it can be absorbed into it, right? And different frequencies might be absorbed or bounced off, resulting in the object appearing to have a particular color. So if all of the blue light is bouncing off of my shirt and the other lights are being absorbed in, then that makes my shirt appear to be blue. Now, whenever the light then is bouncing off of an object and we look at the object, the light that bounces into our eyes is what we see, and that's also going to be what the camera is going to see. Now, once the light actually reaches the camera, it has to be focused into an image, and that's the responsibility of the camera's lens. And so if you're like me and you wear glasses to see, you're kind of conceptually familiar with the idea of using a lens to focus the image. We aren't going to get too much into the detail of all of the physics of lenses today because there's really a lot to unpack there. But, as you know, lenses come in different levels of zoom. The autofocus in the camera makes some little adjustments to bring that image into focus, and it makes it all into a clear picture that can be detected by the sensor. Now, the sensor, when you're ready to take a picture, that's going to measure the light that is hitting it, and then it's going to save it. Again, I'm not going to get into full detail about sensors today because there's a lot of complicated chemistry that has to happen at that point. But if you want to learn that in the future, be sure to subscribe to my channel, and that way you won't miss it. The camera's processor then is going to take those measurements from the sensor, turn them into an image file, and save that to the memory card. Now, viewfinders, I think, deserve a little bit of talking about on their own. And so to enable you to see the picture that you're about to take, we have come up with several different types of viewfinders over the years. So the most logical place for a viewfinder would be directly behind the lens. So light would travel through the lens and it would come right out the viewfinder into your eye. But unfortunately, that's impossible because we have a sensor or film or something in the camera that the light has to hit in order for us to capture the image. And so, that's there blocking your eye, and so, the viewfinder just can't go there. So one solution to that then is just to make a small window somewhere near the lens that will let you roughly see what your photo is going to look like when you look through it. And so that's what this camera right here has. So you can see the lens is down here, and then there's just this little window up here, and that's connected to the viewfinder on the back. So when you look through that, you see approximately what that photo is going to look like. Now, when you have a fixed focal length lens, that works relatively well. Another version of this is the Brownie Hawkeye that I have here, which famously uses a viewfinder that's actually on top of the camera. And so you look down at the camera when you're holding it the right distance from your eye, somewhere around waist level, and you actually see the image on the top of the camera. It does this by having a little window on the front that again is above the lens, and the light comes in and it hits a mirror in there, which redirects it upward and gets focused through a little lens. And so that actually makes it look kind of like there's a little screen on the top of the camera, which is pretty cool. But again, while that works pretty well if you have a fixed focal length, if you have a lens like this on your camera that can be zoomed in and out, as the zoom changes, what you would see through that little window would just become completely wrong. And so to solve that problem, digital SLRs, regular SLRs before them, use a system of mirrors. So when you're not shooting a picture, a mirror comes down in front of the sensor. The light will come in the lens and it will hit that mirror, which directs it upward, and then another mirror up there will be hit by the light, and that will direct it back toward the back of the camera again. And so the light comes in and zigzags through the camera using these mirrors, and then is bounced into your eye that way. And that lets you see through the lens of the camera instead of through a little window, which lets you see pretty much exactly what the camera is seeing. Now, more recently, mirrorless cameras just use the sensor as the viewfinder. And this is as close as we can really get to being able to just put our eye right up to the lens. It just leaves the sensor on all the time. Light comes in, the sensor measures it, and then it can display it on a tiny display, a tiny screen inside the viewfinder, as well as the larger screen on the back of the camera. And this is a relatively recent development just because of the technology required to do that. but it has a few advantages. It's smaller and it's lighter and faster due to not having that moving mirror inside of it that would flip up to take the picture and flip back down again. It comes with better image stabilization, better video recording, better shooting speed, while the DSLR, on the other hand, remains superior in terms of battery life because it doesn't have to power that display all of the time. So to put together all of this overview that we've gone through today, light is coming from the sun or some sort of a light source. It hits an object and bounces off of it. That light then goes through the lens on the camera, where it either hits a set of mirrors, which redirects it through a viewfinder into your eye, or it hits the sensor, which measures it and displays the result on the screen. Then when you press the shutter button, the sensor is exposed to the light for some set amount of time, during which it does some chemistry to measure and record the light that is hitting it. That is then processed by the camera into an image file, and that allows you then to display the image on your screen. So that is where we are going to stop for this video. But obviously there's tons more that I could talk about here. There's a lot of cool science that's happening behind the scenes with lenses and sensors, with aperture, with exposure times, ISO, image processing pipelines, and so on. So definitely hit that subscribe button to find out more. In the meantime though, that is all for this video. Since we are about to start a new month, you can expect to see me out in the field doing some more landscape photography next week, which I'm looking forward to. But in the meantime, as always, thank you guys so much for watching. Don't forget to hit the like button on your way out, and I will see you in the next video.